All right, today we are going to do lesson 15, skipping lesson 14. Um, Obviously, I'm not here today, so I'm recording this video ahead of time so that you can still get the lesson for today. So let's go ahead and get started first on the warm up. So, all books at a bookstore are 25% off. Priya bought a book originally priced at $32. The cashier applied the store wide discount and then took another 25% off for a coupon that Priya brought. If there was no sales tax, how much did Priya pay for the book after both 25% discounts? So the key is that they're applying a 25% discount twice. Okay. So if we use our formula for exponential growth, we use this. We've been using this throughout. Okay. Our initial or starting value is going to be $32. That's our starting value. So $32. And then our discount is 25%. Okay. So if they're taking away 25% of the value, that means they're keeping 75%. So keeping 75% of its value. Okay. So the book is losing 25% of its value twice, so it's keeping 75% of its value twice. So the second number is going to be 0.75, 0.75 because it's keeping 75% of its value. And since it's doing it twice, the exponent is going to be 2. So our answer is going to be 32 times 0.75 squared. All right, so I'm just going to put that in Desmos. Okay, 32 times 0.75 squared. So we can see that after those two discounts, the $32 book is now $18. So that would be how much Priya pays for the book. Again, we have to use the fact that they took off 25%, which means it's keeping 75%. Okay. So that's it for the warm up. Let's get into the examples for today's lesson. So suppose three people each have taken loans of $1,000, but they pay different annual interest rates. So these are their interest rates: 12%, 24%, and 30%. Okay. They're each starting with $1,000. Okay. For each loan, write an expression for the amount owed at the end of each year if no payments are made. So if no payments are made. Okay. So in this case, they're each starting at $1,000, but the interest rate is different. Okay. I want to go back to the slideshow and take a look at the lesson notes for a second. Okay. In the warm up, we were decreasing by a certain percentage. In this problem, we're increasing by a certain percentages. Okay. So, for example, in loan A, they're increasing by 12% each year. So, what that tells me is that my growth factor is going to be 1 plus that percentage. Okay. So, I gave an example here. If I was, say, increasing by 3%, 3% is 0.03. So my second number, my B value, the growth factor, whatever you want to call it, would be 1.03. If I was increasing, say, by 15%, 15% is 0.15, my growth factor would be 1.15. So if we go back to this for a second, if I'm increasing by 12%, 12% is 0.12, which means my B value is going to be 1 plus 0.12, which is 1.12. Okay? That's going to be the number that I multiply by each year, which means, for example, if I want the amount after 1 year, my expression, my equation is going to be 1,000, my starting value, times 1.12 to the power of 1, because 1 year. Okay? My total after 2 years would be 1,000 times 1.12 to the power of 2, because 2 years, so on and so forth. Okay, this one is going to be 1,000 times 1.12 to the power of 3, 3 years. Okay, this one, if we continue the pattern, is going to be 1,000 times 1.12 to the power of 10, because 10 years. And lastly, if we want to generalize it, it would be 1,000 times 1.12 to the power of x, meaning my exponent would be however many number of years we want to go. Okay? So again, to recap, all I did was I knew my starting value was 1,000, and then to find the second number, the B value, I took 1 plus the percentage. 1 because I was increasing by a certain percentage. If I wanted to do the same thing for loan B, all I would do, okay, let me get rid of this here. Okay. If I want to do the same thing for loan B, okay, loan B has an interest rate of 24%, which means my growth factor, my B value, is going to be 1 plus 0.24, which is 24%, 1.24. Essentially, my answers in this column are going to be exactly the same as the answers in this column, except replace the 1.12 with 1.24, increasing by 24%. So this will be 1,000 times 1.24 to the power of 1, 1,000 times 1.24 squared, 1,000 times 1.24 cubed, 1,000 times 1.24 to the power of 10, and 1,000 times 1.24 to the power of x. All right. So we just used the fact, for example, that 12% is 0.12 and 24% is 0.24. Loan C, our interest rate is 30%. So 30% is 0.3. So the only thing that's going to change, let me get rid of this. Okay. The only thing that's going to change, this is going to be 1 plus 30%. So 1 plus 0.3 or 1 1.3. Okay, so my third column is going to be exactly the same as the first two, except that second number is going to be 1.3. This will be 1,000 times 1.3 to the power of 1, 1,000 times 1.3 squared, 1,000 times 1.3 cubed, 1,000 times 1.3 to the power of 10, and 1,000 times 1.3 to the power of x. Okay, so that is our answer for this table here. And by the way, I do realize that there is a typo here. This should be numbers 1, 2, and 3, not 4, 5, and 6. But we'll go with that. So these are our answers for the table. Again, to reiterate, we saw in the warm-up when we're decreasing by a percentage, okay, we essentially subtract the percentage from 1. It's how much you have left. But when you're increasing by a percentage, okay, it's 1 plus the percentage. So 1 plus 12%, 1 plus 24%, and 1 plus 30%. So that is this first one. Okay. The second problem, use Desmos to plot the graphs of the account balances. So I have another tab up here with the graphs. So all I did was I took what I had already done here. I took my equations and I plotted those in Desmos. Okay. So you can see here, clearly I don't have, clearly I can't see the graphs because they're starting at 1,000, and we can see up here it only goes up to 6 to 8 here. So what I'm going to do is I'm going to click on the wrench here and fool around with the window. Since we're starting at 1,000 and it's going to only get larger from there, I'm going to say let's go up to 2,500 on the y-axis. And once I do that, I can see I get a much better view of the graph. I have 1,000. Okay, and then I'm going up from there. Notice that the third one, the green graph, which is increasing by 30% each time, that's increasing at the faster rate, and the graph is taking off quickest. Okay, whereas this one, the first one, which only has a 12%, only going up by 12%, is not taking off as fast. So these are our graphs. Okay. So use Desmos to plot the graphs of the account balances. We did that. Based on your graph, okay, based on your graph, about how many years would it take for the original unpaid balance of each loan to double? Okay, so in this case, they want to know how long it will take for the original balance, which was $1,000, to double. In other words, how long till it gets a value of $2,000. So I've showed you this before. One of the good things about Desmos is you could drag your mouse along each curve to get an idea. Okay. Another thing you could do is I could add another graph of y equals 2,000. Again, why 2,000? Because 2,000 is double 1,000. And one of the good things about that is now I could actually click on each of the intersection points and see how long it actually takes for it to get to 2,000, for the balance to get to 2,000. So if we start with this first one here, the one that was going up by 12%, that's going to be this one. So you can see it takes loan A we'll say 6.1 years to double. So loan A, okay, loan A takes 6.1 years, according to Desmos. Okay. If I look at the second one which had the 24% interest rate, so going up by 24%, that's this middle graph here. This one, it takes 3.2 years, about half the time. So loan B takes approximately 3.2 years to double from 1,000 to 2,000. Okay. And then loan C, let's take a look at that. That one is the one with the largest interest rate, so it's taking off quickest. It's this third graph here. This one, it takes a little over 2.5 years to double. So we'll call that 2.6 years. Okay. So we can see the larger the interest rate, okay, 12%, 24%, 30%, the larger the interest rate, the lesser amount of time it takes for the value to increase, which is what we would expect. Okay. So that is it for today's lesson. I would suggest watching this video back in case you need any need to go back and see any of these problems. Okay, the cooldown is on the slideshow, so you can go back to your slideshow after watching this video and complete your cooldown for this lesson.